So on this warm-up 18, I want to make sure that you're comfortable with the two different kinds of sampling distributions, proportion and mean. We've been mostly doing means. In class, we did a lot of those problems, but this first one is a proportion problem. Now, on this first problem, it does not give us information either that it is a normal curve. So it says, according to the Gallup, about 33% of Americans polled said that they frequently experience stress in their daily lives. So suppose you are in a class of 45, so that would be your sample. And what's the probability that no more than 12 students in the class will say they frequently experience stress? All right, so it says, make sure that you identify the sampling distribution and check the necessary conditions. So it's telling you to make sure that you do that. So those, of course, you have to get real to make sure that it's normal. So our first one is random. So is our sample taken randomly? And it does not say that it is. So we write that we assume that the sample of 45 is representative, because that's the goal, representative of all Americans. Okay, because it looks like, according to this, when it says 33% of Americans, it looks like the population is Americans. So therefore, the P, the population proportion of Americans that say they experience stress is 33%. Okay, all right. So next is independent. So to test for independence, you have to make sure that your sample is not changing the probability of the next thing happening. And in order to do that, your sample needs to be less than 10% of the population. And I think 45 is less than 10% of all Americans. So we're good there. And the last one, is it large enough? Okay. For means, large enough is greater than or equal to 30. But that is not the large enough for proportions, because this is a proportion problem. The reason you know it is a proportion problem is because it's giving you percents. So large enough for proportions is n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. So at least 10 successes or failures. And so that would be 45 times 0.33, and that's 15. So that is greater than or equal to 10, which makes the other 30 also greater than or equal to 10. So since these things have been met, then I can conclude with the fact that the normal model applies. Okay, so you want to conclude and say that's why I just did all of those, is so that I can tell you the normal model applies. All right, so you have has a whole bunch of um, p hats in it. You have got yourself a sampling distribution with a sample of 45 and the proportion that experience stress. 45 and the proportion that experience stress. 45 and the proportion that experience stress, and so on. The mean of a proportion distribution, do not put mean of x bar, because that would be for a sampling distribution of means. On the formula chart, the mean for proportion sampling distribution is the population P. So in this case, that is 0.33, or 33%. The standard deviation for a sampling distribution for proportions is this formula here, not the mean. It is this one right here, where you do P times 1 minus P over N square root. Now, when you do that, make sure that the number you are using in here is the 0.33 times the 0.67 over your 45 and square root that. That makes your standard deviation. 0.07. So the mean is at 0.33. The question is saying, what's the probability that no more than 12 students, you need to write that as a proportion. You need to have that as your sample proportion, not number of students, but 12 over 45. And 12 over 45 is 0.267. So that or less is what you are trying to find, the proportions that you are trying to find. So you get a z-score with that proportion minus the mean proportion over the standard deviation. That is a z-score of negative 0.9. And when you norm CDF from negative infinity to negative 0.9, you get 0.1841. So that would mean 18.41% of samples of size 45 have no more than 12 out of 45 having stress. Say that they experience stress. Okay, now in part B, if 20 of the students say they experience stress, would you be surprised? So in other words, if you got a sample that was 20 over 45, if your p-hat was 20 over 45, where would that be on the curve? Would that be unusual? That proportion is 0.44 repeating. And so I want to find the z-score for that. So the z-score is compare your sample proportion to your mean over your standard deviation, and that is just 1.629. So I don't think it's unusual because it's within 2 standard deviations. So it is not unusual since 20 out of 45 is less than 2 standard deviations away from the mean. All right. And so this last problem is an additional problem. So we actually have to start with the conditions all over again. So we're going to do random, independent, and large enough. So random. Let's see if the samples are randomly taken. Yes, it is stated that they take a random sample of 25 students, so I can write stated. That's good. Independent. Independent is that from sample to sample, the probability is not changing. That means 25 is less than 10% of all ACT test takers, and I think that's certainly reasonable. And then the large enough. Okay, here's an issue that I would expect you, to maybe have problems with. N is not greater than or equal to 30 because for means, N has to be greater than or equal to 30. It's not, but because 25 is not greater than or equal to 30. The thing that you probably don't really know is that standardized tests such as this, ACT, SAT, all of those ones, they do the scoring system so that the parent population is normal. So because the population is normal, then it's okay to not be large enough. All right, and I understand that's something that you did not necessarily know, but that's kind of one of the things they do with standardization is they make it such that they all will fall as a normal curve. Okay, so here we go. The mean of the population is 21.4. So we're going to say then the mean of the sampling distribution is also 21.4. The standard deviation of the sampling distribution of samples of size 25 is the population standard deviation divided by the square root of 25, the sample size. And that number is 0.21. Okay, so now the question is saying what proportion has a average greater than 22. So I'm going to find my z-score. which is going to be 22 minus 21.4 over 0.21. That is a z-score of 2.857, and I want to know that or higher. So then I norm CDF from 2.857 to 99, and that is an area. So the probability that I get an average greater than or equal to, or it's more than 22, is 0.0021. That is just 0.21% chance that you get 25 students that average 22 or more. So not very likely. Okay, 20 chance. Remember, we want to write our answers as a sentence. That, and then you'll go up to the problem that the average ACT is 22 or more. Okay, maybe did I write a sentence up there? Okay, yes I did. All right, so there's your problems. Make sure you keep these symbols of proportion versus mean straight, and make sure that you know your difference in the conditions and you do your conditions for mean and proportion. Oh, I forgot to conclude on this problem right here. I forgot to conclude that the normal model applies. All right, so I think that's everything. So good luck on your quiz.